In this video, we're going to talk a little bit about writing a quadratic equation if you're given a graph. And the deal with writing these equations depends on what information you can easily say what is the easiest way to draw the graph. So we're going to talk about the three basic forms. We got the vertex form, y equals a times x minus h squared plus k. We got the factored form or intercept form, which is a times x minus p times x minus q, and the general form, which is ax squared plus bx plus c. To start off, if you are looking at a graph and you're trying to write the equation, don't mess with general form. To put the equation in general form, either you're going to have to take enough data from the graph and do a system of equations, do a regression with your calculator to put it in that form, or you're going to write it in one of the other two forms and convert it. From a graph, the vertex form and the factored form are the easier ones to write if you have the right information, if it's easy to come off the graph. So that's what I'm going to focus on. So let's start looking at vertex form. Vertex form should look kind of familiar because we did this when we looked at transformations. Because it's basically, the vertex form is a translation and a dilation of the parent function y equals x squared. So the points h and k, h is just your horizontal shift, k is your vertical shift, so that gives you the vertex. That shows how the vertex is shifted. A is just your stretch factor, and it also will give you your reflection. If it's negative, it's flipped vertically. It's upside down. So we have, if A is positive, it's happy, smiling. A is negative, it's sad, it's frowning. So if we have a graph like this one, if we can read the vertex easily, then it's easy to put it into vertex form. On this graph, we can read that coordinate off pretty confidently. That's the point 3, negative 5. So I know my h value and my k value. From here, I have most of my equation already. My equation is going to be sum a times x minus my horizontal, my x coordinate, plus my y coordinate. So I have x minus 3 squared minus 5. All I need to do now is find out what my a value is. That we're going to do just a little work. It's not too bad. The trick is, I only need to find one thing, so I only need 1 point to do that. So I'm going to find some point besides the vertex that I can read the coordinates very nicely off the graph. So I'll take a look at that point. That's the point 1, 1. So I'll plug that into my equation for x and y. 1 equals a times 1 minus 3 squared minus 5. And I'm going to solve that equation for a. So as I go through and plug that in and calculate that out, I'm going to get my a value is 1.5. So I plug that back into my equation, and the equation of this parabola is going to be y equals 1.5 times x minus 3 squared minus 5. If you can read the coordinates of the vertex, vertex form is a very easy way to write the equation. Now let's look at intercept form. This form, we sometimes call it factored form. We call it factored form because if you look at the equation, it's in factored form. We're multiplying 3 factors together to get our equation. But we also call it intercept form because those values of p and q are my 2 intercepts, my x-intercepts. Sometimes we call them zeros, sometimes we call them roots. But those are right out of the equation. The a does the same thing as it did in the other form. So if I can read the coordinates of those intercepts easily, and right here I have one at negative 3, 0, and I have one over here at 5, 0. I have my p and my q. And it doesn't matter which one is which. But we have those values we can plug straight into the equation and say y equals a times x minus a negative 3 times x minus 5. Now, just like on the other problem, all I have to do is find an a value. So to find an a value, again, I'm just going to find a point I can read off the graph. That looks like 4, 10. And plug that into my equation. 10 equals a times 4 plus 3 times 4 minus 5. And then I solve that for a. As we work this through, we are going to get to a is a negative 10/7, or a is approximately a negative 1.4. So now we can plug that a back into my equation, and I get the equation of this parabola is y equals a negative 1.4, x plus 3, x minus 5. And now notice, this one has a negative a value, and it opens down. As we said, if a is negative, it's opening down. Another way to double check. If I can read the intercepts, the roots, easily off the graph, then this is the easiest way to write the equation. If I can read the vertex off the graph, then that's the easiest way to write the equation. Do it whatever way is easy. Then we work on switching other forms if we need it to have in another form.